we're going to start off with solid. One of the properties of a solid is that it has a fixed volume and shape. And why? Is because the particles are locked into place and they can't move. So basically, it's rigid, and like the particles, they're like just barely vibrating, but they can't move because their electrostatic energy just keeps them all together. Alright, the second property of a solid is that it's not easily compressible. And that's because there's not a lot of free space between the particles. And it can't become any more dense to fit into like small spaces. For example, my fist into my other fist. Doesn't work. A third property of a solid is that it cannot flow easily. And that's because it's rigid, like I said before, and it cannot, like, the particles cannot move or slide past one another. So rock, you never see a liquid rock. In my hand, it's not liquid. Stop messing with me, man. Wait, did I make it to a minute? Alright, so the first property is that it retains a fixed volume. So you see, it's not like flowing onto the bed and spilling everywhere. And the second volume is that it's not easily compressible. So like I can't fit it like anywhere, you know. And the third one is that it does not flow easily. Right now it kind of is because it's turning into water, but like as an ice block, it's not spilling onto the bed. So that's a good thing.
Liquid.
Okay, so the first property of a liquid is that it can assume the shape of its container. That's because the particles can move and slide past one another. So when it's in a container, it can shape into the shape of the container. Can you hand me that, or child? Like this. So the second property of a liquid is that it's not easily compressible, and that's because there's a lot of space between the particles, but it just can't be compressed. For example, like a liter of soda can't be compressed because it's a measurement, and a measurement can't be changed. A third property of liquid is that it can flow easily, and that's because the particles, they can slide and move past one another. You see, it has a defined volume, but it doesn't have a defined shape. So it can like go into any shape it needs to, but like if it's 1 liter, it's gonna stay 1 liter. Okay, so you see, for the first property, assuming the shape of the container, it assumed the shape of the balloon to like adjust to whatever it needs to be, and it's not easily compressible. So if I squeeze it, it's just gonna like go everywhere, you know, it's everywhere. And then it can flow easily. As you can see, it's just like swishing around and like moving and stuff. And yeah, that's water.
Gas.
Fine. So the first property of gas is that it can assume the shape and volume of its container, because the particles can move past each other and they can slide past one another. So like in a balloon, for example, you can like compress it and whatever. Okay, for the second part, it's compressible. That means that it can be compressed into a smaller state, and that's because the particles, they're moving around and they have a lot of free space where they can bunch together. For the third property, it can flow easily, and that's because the particles, they can move past one another and they're not attached to one another, so you can go wherever they want, basically. Okay, so for the first property, assumes the shape and volume. Basically, you can compress this and it'll take the shape of the balloon, however it is. And yeah. And for the second property, it's compressible. Like I said, it can be like compressed, and it can be like condensed, basically, and flows easily. As you can see, it's like moving around, and it's not to a certain definite shape or volume. And yeah. Thanks, cameraman, aka Robert, my brother.
Thanks to the cameraman, Robert. Okay, now get closer to the yeah. Alright. And now to Camaron with vaporization.
Vaporization. Vaporization is a change from a liquid to a gas, and normally occurs when you heat the liquid up to the point where like it's boiling and all the smoke coming up is the act of vaporization. An example of vaporization would be when you're making like ramen or something, and you're heating up the water to make the food, and it causes the water to boil, and then, like I just said, it starts steaming everywhere, and that causes vaporization. Next is condensation, and that condensation is the change from a gas directly to a liquid. It generally occurs in the atmosphere when warm air rises. It cools and loses its hold to water. An example of this would be if you have a cold glass on a hot day, and the cold glass starts looking like it's sweating, and all like the water coming off of the cold glass is like all wet. And yeah, deposition's next, and it's a change from a gas to a solid. It's the process where a gas changes phases and turns directly into a solid without phasing into the liquid stage. An example of this would be water vapor to ice. Water vapor transforms directly into ice without becoming a liquid, and it's a process that often occurs on windows during the winter months. Next, we have sublimation. Sublimation is a change from a solid to a gas. Sublimation is the transition of a substance directly from the solid to the gas phase without passing through the intermediate liquid phase. An example of sublimation would be dry ice. Solid carbon dioxide is known as dry ice, and it sublimates at room temperature. Freezing, the change from a liquid to a solid. Freezing is a direct change from a liquid changed directly into a solid. This can be done by dropping the temperature so much that the liquid freezes into a solid. An example of this would be making ice or popsicles or anything around that nature. Melting. Melting is the change from a solid to a liquid. Melting is direct change from solid to a liquid. This can be done by raising the temperature to the point where an item gets so hot it begins to melt. An example of this is if like your ice cream starts dripping on your hands or something like that. That's because the ice cream is so like in such a hot area that it begins to just melt. And that's it. Bye.